Hello students, we have already seen some reactions of ethanol like dehydration reaction, reaction with sodium metal, oxidation and combustion reactions. Now let us continue with the remaining reactions, that is esterification, dehydrogenation and halogenation reactions. Let us first learn about esterification reaction. As the name suggests, during this kind of reaction, esters are formed. And what is the functional group of ester? Correct. It is RC double bond O OR dash, where R and R dash are any alkyl groups or compounds such as methyl, ethyl, propyl, etc. So here if ethanol is made to react with organic acid like ethanoic acid, commonly called acetic acid, in the presence of sulfuric acid, it forms an ester, ethyl acetate. And what will the chemical reaction look like? Yes. Do you know, students, that esters are usually sweet-smelling substances, and that's why they are widely used in perfumes and as a flavoring agent. Now, students, pause the video and look at your screen for a second. Does this reaction remind you of something? Isn't it a kind of acid-base reaction? Yes, it is. If you observe carefully, ethanol is organic base with OH, and acetic acid is organic acid with H, and both react to form organic salt and ester, ethyl acetate plus water. So it is a kind of similar to inorganic acid and base reacting to form salt and water. And what is this called? Yes, neutralization reaction. Now going back to ethanol, let us learn about dehydrogenation reaction of ethanol. What do you think this dehydrogenation reaction means? Is it related to dehydration reaction that we studied in our previous video? No, not at all. Students, dehydrogenation means removal of hydrogen atoms from the compound. Don't confuse this dehydrogenation with dehydration. In dehydrogenation, hydrogen molecule is removed, while in dehydration, water molecule is removed from the compound. So let us try to understand this reaction with an activity. For this, we take a test tube and fix it horizontally on a stand like this. Take a glass bowl soaked in ethanol and place it inside the test tube like this. Also place copper pieces near it. Now fix a condensing tube or connecting tube with the help of cord at the open end of the test tube. Keep the other side of this connecting tube submerged in the beaker containing water. We also place the test tube inverted like this to collect the liberated gas of ethanol over this condensing tube. Now heat the glass bowl by heating the test tube with the help of burner. This produces fumes of ethanol. As ethanol's boiling point is very low, these fumes or gases pass over copper metal and result in the formation of ethanol. This ethanol gets collected in this other test tube which is placed in the beaker. As you can see, as and when the ethanol gas fills the test tube, the water level in the test tube decreases, which means more and more gas is getting filled in this test tube. Now collect this gas and fix airtight rubber cork over the test tube and allow this to cool for some time. We see that colorless liquid is formed. This liquid is nothing but ethanol. Well, it can be confirmed by conducting several confirmatory tests in the laboratory. So you can ask your lab teacher to demonstrate this activity to you. But for now, let us go back to our reaction. So in dehydrogenation, When ethanol vapors are passed over a heated copper at 573 Kelvin temperature, it produces ethanol or ethane aldehyde and hydrogen gas. Students, here copper acts as a catalyst and does not take part in reaction itself as reagent. It just facilitates the removal of two H atoms to form one molecule of ethanol and hydrogen gas. The chemical equation of this reaction is on the screen. And this is how dehydrogenation takes place in ethanol. The functional group in ethanol, as you know, is aldehyde. The two H atoms so removed forms hydrogen gas. And last in the list is halogenation reaction of ethanol. In this reaction, one or more hydrogen atoms are replaced by halogen atoms. And what are halogen? They are elements which readily form salts. It is very evident, students. Word halo means salt. Thus, halogen family includes elements like chlorine, fluorine, bromine, iodine, which readily form inorganic salts by combining with metal elements. Now going back to ethanol, when it reacts with any halide compound, it forms ethyl halide. Say for example, if ethanol reacts with HCl, it forms ethyl chloride or chloroethane. The reaction looks something like this. Or if it reacts with bromine, it forms ethyl bromide or bromoethane, and so on. Now same holds true for all other halides also. Thus we can generalize as ethanol reacts with halide compound, it forms respective haloethane or ethyl halide. This is how ethanol forms different compounds by reacting with different reagents. In the next video, we will learn about another important carbon compound, which is ethanoic acid.